In this chapter, we're going to start our work with ratio and proportion, and I've written over here on the board the definition for the ratio of two numbers. If A and B are any two numbers, then the ratio of A to B is A over B, where B is not equal to 0. So as you can see, ratios are fractions. For example, the ratio of 6 to 8 is the fraction 6 over 8, which of course we can reduce to lowest terms as 3/4. So the ratio of 6 to 8 is equivalent to the fraction 6/8, which reduces down to 3/4. Likewise, the ratio of 15 to 3 is 15 over 3, or 5 over 1. Now, a lot of times when we work with ratios, we'll say 15 over 3, that looks like this as a fraction, then that would reduce normally just to 5, but many times we're working with ratios, we leave that 1 in the denominator. Let's go to the board now and try some problems where we take ratios and convert them to fractions. Problem number 1, we have 64 to 12, and I want to write this ratio as a fraction in lowest terms. So 64 is in the numerator, 12 is in the denominator, and then I simply have to reduce this to lowest terms. So let's see, I'll divide this numerator by 4, and I get 16, and I'll divide the denominator by 4, and I end up with 3. So the ratio of 64 to 12 is the same as the fraction 16/3 in lowest terms. Now what we want to do is look at a second problem that involves the ratio of two fractions. So I have 3/4 to 1/4. I want to write that ratio as a fraction in lowest terms. Well, this is the same as 3/4. That will be in the numerator, and then that number will be in the denominator. Now I have a complex fraction, so I'm going to write this as 3/4 times, and I'll multiply by the reciprocal, just like I did when I simplified complex fractions. Those 4's divide out, and I end up with simply 3 over 1. And since I'm working with ratios, I think I'll keep that as 3 over 1. If I was working with just regular numbers and that, I might simplify it down to just 3. But since we're working with ratios, let's leave it as 3 to 1. Here's our next problem. How about the ratio of 2 2/3 to 5/3? Well, here I have a mixed number, here I have a fraction, but the idea behind these doesn't change. It's still 2 2/3 in the numerator and 5/3 in the denominator. Now, I'm going to change this numerator, that complex, not complex number, but that mixed number into a improper fraction. 3 times 2 is 6, plus 2 is 8. So I have 8/3 in the numerator, divided by 5/3 in the denominator. Now, instead of dividing by 5/3, I'm going to multiply by its reciprocal. So I have 8/3 times the reciprocal of this, which is 3/5. The 3's divide out, and I end up with just 8/5 for that. So that improper fraction, 8/5, is in lowest terms, so I think I'll just leave the problem that way, as 8/5. If I was just working with numbers, I might change this into a mixed number, but since we're working with ratios, that is a ratio or a fraction in lowest terms. We'll just leave it at 8/5. Here's our next one. How about 2.5 to 3/2, that ratio? Well, here I have a decimal and a fraction, but still, the first number goes in the numerator, the second number goes in the denominator. So it's 2.5 over 3/2. Let's see if we can simplify that. How about 2.5 over 3/2 is the same as 1.5 or 1.5. Let's see, I can multiply numerator and denominator by 10. I would have 25 over 15. I'll divide the numerator and denominator by 5, and I'll end up with 5/3 as that fraction in lowest terms. So this time, it turned out to be the best thing was to change this fraction into a decimal, and then multiply numerator and denominator by 10 to get a little bit easier numbers to work with, then reduce to lowest terms, and I end up with that fraction. Again, an improper fraction, but still, it's the lowest terms equivalent of this ratio right here.